Hi, I'm John Tribbs, and I just built a rainwater catchment system for my house, and I'd like to show you what I did and how I did it. The purpose is to save rainwater for plant irrigation during our dry summers here in California, and also to have emergency water in case of when the big quake happens in any time in the next 50 years. Now, roof water is not usually potable because you have bird droppings and roof chemicals in it, but will be used if necessary after we filter it and maybe boil it if we can using campfire stoves. They'll be as last resort in a dire emergency. So there's some safety features here that sort of like convinced me to go ahead with the system. Now the plants prefer rainwater over tap water, but recycled is best. But I'm going to have gray water projects in my future. That's on my to-do list down the road. Now some of the requirements that I have for this system is that it needs to provide enough water to make it worthwhile for me to put this effort in, not too ugly so it gets more acceptable to my wife. It needs to have some ADA rated path between itself and the fence line, which puts some limitations in. And I want to be able to get to that backyard area in there so I can do some landscaping and work back there. And I almost went for a 1,000-gallon tank, but that was just a bit too big for this space. It would be workable. I could get the ADA to 36 inches, still be there, but it'd still be a little bit too large, a little bit too big, not quite acceptable. So I ended up buying a 500 water gallon tank, poly tank from American Tank in Windsor. They gave me a good price on it, $450, less than $1 a gallon. I used the Fisker's rain diverter, which I got off Amazon for $30, or you need to get it from other stores. And then I have a bunch of parts that I bought from a variety of stores here in town, mostly from Friedman's and Water Savers and Wirettes, irrigation. And so all of that kind of added up. Also, I used Sonoma Marin Landscaping. And so it added up to about $170, but probably even closer to $200, I would say. Total cost is going to run about $700 for the 500-gallon water system, which comes to about $1.40 per gallon of storage. I wanted a wider path, think ADA and resale value, to get to the landscape behind the barrel and down the way. Eventually, I'd like to put in a solar-powered fountain outside the living room. Right now, I have some vines and some containers, large ones, with drip systems involved to kind of look at from the living room. Now, the other thing I added was this metal frame arch, which I had some plants on earlier, but removed and I'm going to reestablish. But the frame is going to go down, and it's an arch. And then there's going to be a plant and vine around it, so that way I give a visual block to the tank. So in your backyard, you don't have to look at the whole tank. You have a little bit of a blockage. And then I had to reroute the gutter behind the tank from the downspout around the corner, around the sprinkler head, down the wall to avoid any water getting too much or too soaking wet right by where the tank is. Now the pad and tank install was a little bit more difficult than I thought it would be. But they wanted a 5-foot circle of pad underneath the 4-foot of tank, and they wanted it 6 inches deep. So so I had to remove a bunch of clay soil, which wasn't easy, and that we're talking about 1/3 of a cubic yard of soil got removed and hauled off. Then we added in the various gravel. But first we put in this weed mat, and then the gravel, and along with the wood borders. Now the wood border is a little bit more difficult to put in than the aluminum, which at 16 foot and 4 inches wide would have just been a perfect 5-foot circle. You put it down, but I wanted a little stronger system than that. And besides, they were out of the aluminum strips at the store when I went down there, but they had the wood. So we tried the wood, make an octagon out of it, 8-sided, 22-degree angles, 2 foot long to create a 5-foot octagon. But I wanted a little bit further from the wall, so I ended up being a 9-sided, but all of them pretty equal. And having the 9 sides made it a little more circular and away from the wall and gave me a little bit more of a pad. Now we want this soft gravel went round 3/8 inch so that if the tank doesn't sink into the ground but is supported but doesn't have any scrape or sharps in it that might pierce the tank at any point causing leakage. So you want this nice soft strong sturdy pad. Now the 1/3 cubic yard that's required of this gravel is equivalent to 74 gallons of material. So I used 15 full 5-gallon pails, taking 2 trips of like 7 to 8 5-gallon pails each in my minivan to the landscape store to pick up the rocks and then deliver them in. I find it easier to carry them in the 5-gallon pails through the backyard, the gate, a little easier to maneuver around than the wheelbarrows. Since small amounts, just many more trips, but I find it more easier in using my minivan. Fewer ins and outs of the pails. This section of the roof is my cleanest portion of the roof. There's some trees in the front area that put debris down, and also on the other side, other tall trees that put debris on the roof. But this side remains fairly clean, so I decided to use this side. Also, we have a hidden area back there. It's hidden from the windows seen from the house, and it's hidden from the neighbors by the fence. So it makes for a very nice spot, and you have a large roof system going down to a single spout. And you can see that there's actually 3 sections of roof all funneling down into a single funnel. So for the diverter, to maximize the water flow and have simplicity of plumbing. On the right side, in the backyard, you'll see there's some raised beds where we keep our vegetables. I did retire my lawnmower about 3 years ago, and by putting in raised beds in the back and native plants in the front yard, which I did happen to grow at my native plant nursery at the school that I taught at. We were able to use the old downspout, but it's a little smaller. It's only 1 3/4 inch by 2 3/4 inch compared to other gutters, so it's a little on the smaller side, and it is smaller than even the adapters, the small adapters given to us by the Fisker's Diverter. So we had to cut the front corners and angle it a little bit inward so that the water would flow off of the front side of the gutter toward the back side to get maximum catch. Several reviewers of this product have talked about that the sizing of the plastics didn't quite meet the size of the gutters that were in their area or on their house, and they had to make a lot of adjustments, and as did I, some handcrafting to get the water flow right and the funneling right in and out of these tubes. Now the black tube that enters into the diverter leaked at first, but I realized that was my fault for not getting a nice clean cut on the outside larger ring of the tubes. So after I did that and reattached them, they were able to snap in place much easier and made much better. The other thing I did on the downside of that black tube, I added electrical tape around it, and then it fits nice and snugly into that 1-inch coupling that goes into the PVC pipe system. Now, right up below the black Fisker's Diverter, you notice that looks like a funnel system. Go down and more on that later. I rebuilt the bottom end of the gutter system so that moves water far away from the tank area, so minimize any water saturation right next to the tank, so minimize any sinking that might happen from the soggy clay soil, which tends to move in this area quite a bit. Also, I've by having the extension out, instead of using the 8-sided wood, using the 9 sides, using the cement wall of the foundation as the 9th side, I was able to expand the size of the pad just a little bit so that next to the wall I have a full 6 inches away from the wall and 6 inches all the way around also. I upgraded the stove vent that came out on the inside of it by using a special tube of membrane that actually collapses so that I have better airflow out and very little cold air coming into the house. But I need to have access to both the air vents and to this vent. Again, another reasons for a smaller tank. Now you note that on the right side there's also an outlet, and if I needed more flow I could add a second tube to the right side, and then that would come below and then tap that right into the PVC line using a T. And so if I needed more water flow, if this one tube wasn't enough, I could add a second one, but I don't think I need to do that. The clear plastic window is easy to remove, as is the leaf catcher and water catcher system. Very simple design, nice curves to it. Water flows over and around and down if there's excess water, but catches a fair amount of water and sends it right down the tube. So it's a pretty nice system. The one concern I may have is on the plastics, both for UV light coming in for plastic breakdown, but I'm hoping that will get minimized if they use a good UV protection on it. and also it's on the sunny side of the house, so once the sun comes out, it should dry quickly to keep the moss down. I tested the system by using a hose, which puts out about 10 gallons per minute, and put that up on the roof above it, and then watch the water flow coming down. And we still captured a fair amount of water. There was some good overflow though, but I never expect to see 10 gallons per minute in this area. That's way high of rainfall for what we see here in California. It's more in the range of 1 to 2 gallons per minute at most, even in the heavy rainfalls. Now note that there is a slight leakage there on the left side where the tube comes into the box, but I was able to correct that by doing a better, more even cut on that tube. Over on the bottom right, you'll see that I used a variety of tools. The sheet metal screws actually tell you on the back what size holes to make, so pretty easy to put those in. Once you've folded it and trimmed all the edges off, got all the little bits and pieces off, made a nice square top and a square bottom, and then put that in. The two elbows, which are 45 degrees, do help in, and I was able to turn those and adjust them so that I could get the above pipe right next to the wall, flush against the wall. Now in line, as the water comes down, there's a little bit of head pressure, enters into the filter, which is just a standard drip line filter used on 1-inch lines, and we'll show you that next. And then as it comes through the elbow into the first flush system, which is the tube that comes down, and then after the water fills that up and flows on, it gets past the overflow tube and then into the tank finally. So I have the water's being filtered in the gutter, it's being diverted and filtered for large pieces in the diverter, and it's also filtered again in the metal mesh, and I'm capturing the first flush for a chemical capture, that first flow out, because of all the bird poop and chemicals off the roof that may have accumulated, whatever's on that roof coming down, which then comes out the bottom of that white tube. Now I used this 1-inch drip line filter, and it only cost about $12 for it at the irrigation store. Now there's a larger filter systems that go up in size to 1.5 inch. They were from Israel, and very nice, beautiful plastic and metal engineering going on with those. But those were $55 to $75. And if I had a larger system, I would go with one of those filters instead. Now you can open up the filter pretty easily, just hand twist off, and there's a round tube mesh, fine mesh filter on the inside. But you don't need to open that up very often, because you can open up the bottom, just open up the cap and flush it out with some water, and all the grit that's accumulated will then just fall right out there. Okay, this is the first flush tube system that I created. Because of a smaller flow rate, I wanted a smaller quantity in the flush tube, so I just used the 1-inch tube that's 2 foot long. Now I thought I started with a really good design here using the cork, but just shaving it down, and it fits right into the top cap there, which is actually a 3/4 inch screw into the 1-inch slip joint, and then the cork will fit right into that to plug up that hole as it floats up. At the same time, I have water going out the tube through dripping at the bottom using a small hole. I first tried a 3 and 30 seconds of an inch drill, and that was too large. I went down to a 1/64 inch drill hole. That ended up still being a little bit too large of a hole for the water coming out. I wanted to even drop that water down, so I'll show you later how I rebuilt this. But the basic concept is a screen on the bottom, prevent the cork from plugging up the hole at the bottom, keep a nice air gap so you have the tube drying out between runs of water, and at the same time water comes down and floats the cork up, and then that first flush of water then can easily drains out, and then you even have constant drainage a little bit, so to keep any grits that may be falling down in and out of the water tank. The hole coming out is actually larger than the 1-inch tube, just slightly, even with the screen, so there should be a good flow out if necessary. If I run into a problem that the water flowing out is too much with the tank filling up and it's forming a big puddle erosion area right below it, in that case I will restructure this and add in a pipe that goes all the way to the ground and then out to where the other gutter is. Okay, at the top of the tank you have a nice large screw-on lid, and in it, that lid, there is a gas release valve, so as the water fills up, the air has somewhere to go out the tank as the water comes in. But the overflow valve also acts in the same way, so allowing the gas release. But if that fills up also, then you still need to have a small amount of movement of the air within the tank. And also for temperature changes, you want to have an air pressure release. Okay, at the bottom of the tank is a 2-inch outlet. So we have use an adapter, run it down to a 1-inch line with a ball valve on it, a standard irrigation valve, and then out to a hose coupling at the back end. So easy on and off, and I'll probably be covering this with some sort of shade cloth because I noticed that the red handles on these at my nursery tend to break down in UV light, so I'll probably end up covering this and shading it out from the sunlight when I'm not using it. Now on the next picture on the right side, I've added in a little cement stone. This is something that was made by my mother a long time ago, and sort of like for sentimental value, and but it's a stone that I've been able to use now and put in a good place, make the place look a little softer and nicer, at the same time keep my feet from getting all muddy or wet and still be able to access the water with a hose. So I'll be using a short hose to fill up a little water tank, and then watering the plants with a spout, or using a longer hose and then water directly in the vegetable gardens. But I want to conserve the water over time because I only have the 500 gallons pretty much this season, because once the rain stopped, they've stopped here in California for like 6 months. Now came the hard part of actually testing the system out, looking at the flow rates I had calculated to make sure it worked, that the system was large enough to capture everything I wanted to capture, but at the same time small enough to allow captures of small flows, because we get drizzly rains here in California. So a hose puts out 10 gallons per minute. So instead of using maximum water, you try to test it between 5 gallons per minute with the hose, so it wasn't on full maximum, but still provided a very strong flow rate, more than anything we would get in a downpour here in California. Now a 1-inch rainfall over 1 hour period, that's pretty unusual. It's more typical that we get a 12-hour drizzle and get 1 inch over a whole day. If we get more than that in one day, was considered a really heavy rain. Now, given it's about a 300 square foot area of roof, that's a single inch of rain is going to generate 25 cubic feet of water, which is about 187 gallons total water. And remember that 1 cubic foot is 7.5 gallons. So even if this falls in 1 hour, that's about 3 gallons per minute maximum flow rate. That's going to be hitting the roof. Now, a drizzly rain will generate much less, probably more in the order of a quart per minute at most. So we're looking at smaller flow rates, much smaller than the 5 gallon per minute coming out of the hose. So that's why my smaller diverter and a 1-inch tubes are just going to be fine. A 3-inch tube system would be overkill, and I want to be able to capture the slow moving water with this smaller system. Now, if I can get 60% of the flow rate, especially even in high flow rates situations, then it's going to take all of about 5 inches of rain to capture and fill up the 500 gallon tank. So here in Petaluma, we're looking at maybe 15 inches in a drought year, 25 inches in a good year. So in the next couple months, February, March, this is an El Nino year, we should be getting about 5 inches of rain. So I expect my tank to be filled in the next 6 to 8 weeks, just with 2 or 3 good rainstorms that we might get here over a 2 or 3 week period. This is a picture and a video of a high flow rate, putting on 7+ gallons per minute with the hose and showing the water flow coming down and how it hits the first diverter system, which goes through, and it still does a pretty good job. We still capture about 3 gallons per minute, even when at this high rate. Now, my first design on that first flush system, there was a problem, too high of a flow rate out of the bottom hole that I had drilled. It was too large, And so on a second go around, I went ahead and added a different set of adapters to the 1-inch screw in at the end, and came on down to a 1/2-inch screw and cap. And then this is attached to a drip line, or actually it's a micro spray unit that you can get from Rainbird or some other manufacturer. But it particularly has a turn ball, a micro ball valve on the end of it. And the tip of it had been broken off earlier, so I used one that had been old and wasted, that was already broken. So I was able to use that just to have a constant stream that comes off. The most important part of this is the ball valve, and so I can control it from a steady stream down to a slow drip, or even to completely turn it off just by turning the ball valve. So I thought that was a pretty nice little trick to get control of that water flow out of that tube. So in this final slide, I wanted to show you the system in operation. I do have using a hose as the test system, putting up there at a moderate rate, maybe 5 gallons per minute, showing there's plenty of flow through the filter that I have going into the tub, and a little video will show that. And then in the tank, after the water drained out a little while and the water's just kind of dribbling down the tubes, I wanted to make sure that I even captured the slow rate. So at the very end of my test, I just kind of kept watching and waiting for the water to come out, and it did for a long time, and there's still continuous flow of water into the tank. So I know it will work at slow rates as well as fast rates. So I'm very pleased with my system, and I hope you do so well with yours.